All right, so we have two objects, accelerate, rest from the same with the same constant acceleration. So let's put up two number lines. We know both of them, the initial velocities are 0. Object x accelerates for twice the time as y. So they both start at the same place. They have the same acceleration, which means the distance is going to increase. But x is going to go on for twice the time. All right, so we can see how far y is, and we can see how x, if it's twice the time, so we had 1, 2, 3, 4 seconds, 5, 6, 7. All right, x is moving at the same speed as y. All right, so which of the following is true at the end of their respective periods of acceleration? So x is going to be way out there, and y is right there. X is moving at the same speed as y. At the end of their periods? No. It's accelerating longer, so it can't possibly be that. It's moving 4 times faster than object y. Well, the way it says that it's constant acceleration. So let's say the acceleration was 2 meters per second. So this would be 0, velocity 2, 4, 6. Well, this would also be 6, and then this would be 8 and 10 and 12 and 14, 16. So 16 versus 6 is not 4 times. And let me just organize that in a table to make it a little clearer. So if we have x and y, it starts at 0, 2, 4, 6, 8. I'll say this is 0, 1 to time. 2, 3, 4, 5, 6, 7, 8. So let's say the x goes for 4 seconds. Or excuse me, y goes for 4 seconds. And at the end of 4 seconds, they're both going at 8 meters per second. But we continue onward. This becomes 10, 12, 14, 16. X is definitely not moving 4 times faster than y. It looks like it's moving twice as fast as y. X has traveled the same distance as y. Clearly not from our picture. X has traveled twice as far as object y. Well, no, we can see that happens about here. It's not even close. It's definitely not that. Well, X has traveled 4 times as far as object y. So just from reasoning this out, it should become clear that that's the answer. A formula we could use, and that you don't know yet, well, actually, we could go about, our first rule is to try to use average velocity. Average velocity is delta x over delta t. And so then the delta x is average velocity times the change in time. So for x, the average velocity, we ended at 16, the average velocity is 8 for 8 seconds, which is 64 meters. For y, the average velocity, average of 0 and 8, is 4 for 4 seconds, 16 meters. And you can see that that ratio, 64 to 16, is 4.